Discuss, hi friends, welcome to Eco Engineer. Today we discuss about switching theory and logical designing. Important questions. The second question is: if a random variable x has probabilities, we know that the sum of all probabilities is equal to one. This is condition you have to know property. Summation x is equal to I equal to 1 to 6. P of x is equal to 1. Here, from the table, you have to see that this is problem. From the table, we have to see that 0.2 plus 0.5 k plus 0.1 plus 0.3 k plus k is equal to 1. 0.3 plus 2.8 k is equal to 1, 2.8 k is equal to 0.7, then k is equal to 0.7 by 2.8 is nothing but 7 by 28. The value is 1 by 4 is equal to 0.25. The p of x is equal to summation of power bracket is open 0.2 comma 0.5 by 4 comma 1 by 4, 0.1 comma 0.3 by 4 comma 1 by 4. Now p of x is equal to some probability open 0.2, 0.125, 0.25, 0.1, 0.075, 0.25. This value substituted in the value in the table form. The cumulative distribution function fx of x is given by fx minus 3 is equal to p of xi is equal to 0.2. Here fx minus 2 is equal to p of x1 plus p of x2. The summation is 0.2 plus 0.125, nothing but 0.325. Now continues this point, fx of minus 1 is equal to p of x1 plus p of x2 plus p of xe. 0.325 plus 0.25 is equal to 0.575. Fx of 0 is equal to p of x1 plus and so on p of x4. That's why 0.754 plus 0.x4 is nothing but 0.1, 0.675. P of x1 is equal to p of x1 plus and so on p of x5. That's why the point c of x4 is nothing but this value. And xy value is 0.075. That's why 0.75 value. P of x2 is nothing but p of x1 plus and so on p of x6. That's value. P of xy value is this point 0.75 plus p of 6 values 0.25, the value is 1. The cumulative distribution function is formed p of fx of x is equal to summation of pxi mu x minus xi. Fx of x is equal to 0.2 mu x plus 3 plus 0.125 mu x plus 2 plus 0.25 mu x plus 1 plus 0.1 mu x 0.075 mu x minus 1 plus 0.25 mu x minus of 2. The density function of x is fx of x is equal to summation of p of xi delta. Here delta is nothing but a impulse function. Here x minus xi. Here fx of x is equal to 0.2 delta x plus 3 plus 0.125 delta x plus 2 plus 0.25 delta x plus 1 plus 0.1 delta x plus 0.075 delta x minus 1 plus 0.25 delta x minus of 2. Here plots of fx of x is. Here what is the fx of x is nothing but the distribution function. Okay friends, now this function is nothing like this. This is a unit function. This is impulse function. Plots of fx of x is a density function nothing but a impulse function, distribution function nothing but a unit function. The values are like this. How do we unit function? This is an impulse function. Okay friends, here Sn is value 0 1 2 minus 1 2 minus 3 0 1 2 minus 1 minus 1 3. Substituting these values from these equations. Substituting these values from this equation. This is the process of this second question, problematic of PTSP, probability theory and stochastic process. Now have to go to third question. Now the third question is the Gaussian density function and distribution function of a random variable x are given by fx of x is equal to 1 by root of 2 pi sigma x square exponential of minus of x minus mu x whole square by 2 sigma x square for all x. Fx of x is equal to 1 by root of 2 pi sigma x square. Here integration of minus infinity to x exponential of minus of x minus mu x whole square by 2 sigma x square dx for all x. Here where root sigma x less than or equal to 0 and minus infinity less than mu x less than infinity are constants called the standard deviation and the mean value of x representatively. The Gaussian density function is also called normal density function. The distribution forms of a Gaussian random variable x, the random variable which satisfies the Gaussian density function is called Gaussian random variable. It can be denoted as n mu x minus sigma x. Here mu x is nothing but is the central moment theorem or central moment value, and sigma x is nothing but variance. This is the variance of central moment. the origin or central moment of the point. Here this is the Gauss. Now how to see that Gaussian density and distribution function. Here, what is the Gaussian density function and distribution function? This is a Gaussian density function. This is a distribution function. The density function is like this. This is a mean value 1 by root of 2 pi sigma x square is a mean value of the Gaussian density function. This is the Gaussian distribution function. Here you have to see that the mean value, the center value is nothing but mu x, and the negative portion is nothing but mu x minus the root of sigma x square, not the root, the sigma x. Here mu x plus a sigma x. This is an x coordinate, this is a y coordinate. You have to see the point 0. This value is nothing but 0.607 by root of 2 sigma x square. This is called capital small fx of x. This is called as a probability density function. Here probability distribution function is represented as fx of x. Here the probability distribution function is mu x minus of sigma x, mu x is mu x plus sigma x. This is the representation of probability distribution function. Gaussian distribution function. This is Gaussian density function like this. This is Gaussian density function. This is the Gaussian distribution function. Now you have to see that the plot of a Gaussian density function is bell shaped and symmetrically about this mean value mu x. The total area under the density function is 1, that is 1 by root of 2 pi sigma x square integration minus infinity infinity exponential of minus of x minus mu x whole square by 2 sigma x square dx is equal to 1. The maximum value of fx of x is 1 by root of 2 pi sigma x square and it's occur at x is equal to mu x. The function decreases to 0.607 times of its maximum value at x is equal to mu x plus or minus sigma x. The distribution function fx of x is 0.5 at mu x, 0.159 at mu x minus sigma x, and 0.841 at mu x plus sigma x. The sigma x signifies the spread rate of the function, and the sigma x square is the variances. Sigma x square is variance. Sigma x satisfies the spread sp or spread of the function. Sigma x is the spread of the function. Sigma x square is the variances of the function. The mean value mu x can also represented with symbol mx or ax. The mean value mu x can be represented as mx or ax. This is the third question. The third question is nothing but the Gaussian distribution function and density function. How to know about this? Third question. The fourth question is what is the right about the Rayleigh probability density function of a random variable x is defined as fx of x is equal to the flower bracket is open 2 by b x minus a e power minus x minus a x minus a whole square by b. Here this value when I had formed here x less than or equal to a, if x is less x is greater than or equal to a, this value is formed. Here fx of x will is 0, the x is less than or equal to a, where a and b are the real constants. Minus infinity to less than a, less than infinity, or b is greater than 0. Now the distribution function is fx of x is equal to minus infinity to x fx of x dx. Here fx of x is equal to minus a to here a to x 2 by b x minus a e power minus of x minus a whole square by b dx. To evaluate the integration, let x minus a whole square by b is equal to y. Here 2 by b x minus a dx is equal to dy. Fx of x is equal to integration minus integral a to x integral a to x e power minus y dy is equal to e power minus of e power minus y by in limit from 0 a to x e power minus of e power minus x minus a whole square by b minus 1. Here 1 minus of e power minus of x minus a whole square by b. Here fx of x is equal to integration of 1 minus of e power minus of x minus a whole square by b is values when the 0 x less than or equal to a, when 1 minus e power minus of x minus a whole square by 2 by b, if x is greater than or equal to a, the 1 is equal to 1 value fx of x value 1, x is equal to infinity. Here the Rayleigh probability density function, the Rayleigh distribution function. Here Rayleigh probability density function is like this, and the distribution function is like this. In this we have to see that probability distribution function, the density I have seen that is like this probability. Here this is the maximum value is a plus root over b by 2. A plus root over b by 2 is the mean value, the peak value of Rayleigh distribution probability density function. Here 0.62 by 2 root 2 by b, this is called as probability density function. This is probability distribution function. Capital fx of small x. Direct distribution function. This is also direct distribution function. From the right point, this is a plus root of b by 2. This is direct point 0.0393 fx of x is maximum point value 1. This is called as Rayleigh distribution function. This is called as Rayleigh probability density function. This is probability Rayleigh probability distribution function. This is probability density function. Now, maximum value of Rayleigh density function. Rayleigh density function is fx of x is equal to integral of 2 by b x minus a e power minus of x minus a whole square by b x less than or equal to a. Here 0 x less than or a. The maximum value occurs at a d of x fx of x dx equal to 0. 2 by b x minus a dot e power minus of x minus a by b whole square x minus a x minus a minus 2 by b plus e power of minus x minus a whole square by 2 by b is equal to 0. A minus 2 x minus a whole square by b plus 1 is equal to 0. X minus a is equal to root of b by 2 or x is equal to a plus root of b by 2. The maximum value occur at x is equal to a plus root of b by 2. The maximum value is fx of x maximum is equal to 2 by b a plus root b by 2 minus a e power minus a plus b by a plus root b by 2 minus of a whole square by b. Here 2 by b root of b by 2 e power of minus 1 by 2 is equal to 0.607 root b by 2. Values like this. Here the maximum value is 0.607 root b by 2 is value of Rayleigh density function. This maximum value of Rayleigh density function is 0.607 root b by 2. What are the applications of Rayleigh density function, probability density function? The decreases the envelope of white noise when the noise is passes through a band pass filter. The Rayleigh density function has a relationship with the Gaussian density function. How to see that Rayleigh density function has relation with the Gaussian density function.